In this video tutorial, I'm going to show you how to use external mesh in TCFD. For this video tutorial, I'm going to use Francis water turbine MSH tutorial from TCFD website. First thing I need to do, when I opened my blank TCFD, I need to create TCFD file. I click on Save As, go to the directory where I have my STL file, where I have my external mesh. It's in Francis turbine MSH, and here next to the folder with external meshes, I'm going to create TCFD file, and I name it tutorial with extension .tcfd. I press OK. I'm not going to set a full case. I'm just going to show how to load external meshes, so I can go directly to section components and subsection components. This tutorial has 4 components, so I need to increase number of components to 4. First component is stay. I need to change the geometry source from directory with STL files into external fluent mesh. Then I need to specify the MSH file which should be loaded. I again go to the directory where I have my meshes, and this time it's mesh MSH, and I select stay segment. Press OK. The MSH file is loaded into TCFD, and I can show it by clicking on the eye next to components, which is now hidden. I click, press apply, and after rescaling the geometry, the mesh is visible. Now I need to change the types of walls or patches used in this external mesh. Blade should be type blade. Hub is hub. Inflow is inlet. Periodic 1 and periodic 2 are periodicities in 3D, so I use rotation AMI for both of them. And besides only specifying that these are rotation AMI patches, I need to connect them. So I need to right click with mouse on this type and connect it to the other periodicity. After selecting, they are highlighted with the same color, and now I know they are connected. Then I change shroud to shroud, and stay guide is the interface between stay and guide components. So it's outlet of stay component, and that's why I'm going to use outlet interface. Now I need to connect this interface into the other component, because there is option to connect this interface with any component, so TCFD needs to know which components should be connected. I right click with mouse and select second component. Then this is periodic segment, and that's why I need to increase number of periodic segments to number of segments which would create a full circle or full machine, and in this case that's 24. Then for segment I have to use mixing planes, and in this case I'm going to use 10. I don't need to specify refinement levels or any other mesh parameters because external mesh is already finished. I only needed to specify types of patches. This is everything to first component, and I can continue to second component. Second component has its own independent setup, and that's why I again need to change geometry source into external fluent mesh. Then specify MSH file. In this case, it's guide. And now I need to change types of patches in this external mesh. Blades are blade. Here, blade. Then guide rotor is interface between guide and rotor interface. Rotor is after guide. That's why this is outlet interface from guide, and I am selecting outlet interface. Guide to stay. Stay is before guide. From stay we had outlet interface, and from guide I need to have inlet interface because this is the inlet into guide component. Then hub is hub. Periodicity is again rotation AMI, rotation AMI, and shroud is shroud. Now I need to connect periodicities. I right click with the mouse, connect, and they are connected. Then I need to connect interfaces. I'm going to connect guide with rotor, and rotor will be third component because it's behind guide. Stay is the first component, so I'm going to connect it with the first component. Number of mixing planes changed to the number specified in the first component, and I'm also going to use 10 mixing planes for the other interface. And the last thing I need to set is number of periodic segments. Guide also have 24 segments. Component 2 is now complete, and I can continue to component 3. I need to specify geometry source, pick specific MSH file, in third component it's rotor, MSH file is loaded. After pressing apply, it should also show in render view. So now I have 3 components. I did not press apply when I set second component, so now 2 components appeared. I again need to specify number of periodic segments. Rotor has 13 segments, so I specify number 13, then change blade type to blade, hub to hub, periodicity into rotation AMI, here I connect them, then rotor draft tube interface is outlet interface because it's outlet from rotor, then rotor guide is inlet interface because it's inlet into rotor from guide, inlet interface, and shroud is shroud. I need to connect outlet interface with the last component draft tube, And I also need to connect inlet interface with second component guide. Here number of mixing planes changed, and I'm also going to change number of mixing planes for the other interface. Then, if I wanted to fully set this case, before I would have specified rotation for rotating reference frame, and I know that rotor should rotate, so I need to change reference frame for rotating. And besides changing the reference frame, I also need to specify which patches should rotate. And that's why I need to also change reference frame for blade, hub, and shroud. Interfaces and periodicities do not rotate. Now the third component is set, and I can continue to the last component, draft tube. Again, external fluent mesh, specify MSVH file for mesh draft tube. I need to wait while it's loaded. It takes longer than expected. But now I can press apply and geometry appears. Now I have full mesh, and I need to only specify the types of patches, because reference frame here is again static. This is full geometry, so I have number of periodic segments 1. Draft tube rotor is interface. It's inlet interface because it's inlet into draft tube from rotor. I also need to connect it to rotor. Number of mixing planes changed. Then mesh draft tube default is wall. I don't need to change it, and outflow is outlet. Now my mesh is complete. I press apply to apply the changes. I press save to save the changes, and to check that my geometry is really complete, I need to, or I can check components graph. And here I see that inlet is connected to inflow patch in the first component. Then there is a thick line between stay and guide, which refers to working interface. Then there is a second component guide with a correct interface between guide and rotor. Then there is a third rotating component, rotor, and the last interface between rotor and draft tube. And draft tube ends with outlet. I do not have any dashed lines, and it means that my setup is complete. If I had any issues, or if you have dashed lines in your setup, it means that your interfaces are not connected correctly. I can close this, because mesh generation or mesh setup is complete. Already after finishing meshing setup, I can go to meshing. I can skip other settings. I need to click on TCFD source, so I'm able to click on TCFD manager. Now it's possible, and I can continue to TCFD manager by pressing apply. TCFD manager is loaded, and I can start with write case. After the case is written, I can continue with meshing. external mesh is a bit larger than usual case, and that's why the write process takes longer. On the other hand, meshing will be much faster because mesh is already prepared. Now I can click on Mesh All. Meshing starts with the first component, and when it turns green, it continues to next component, and so on for third and fourth component. After all components are meshed, the separate components need to be merged. And after merging them, the mesh is prepared for computation and ready. To visualize the mesh, I can click to render view. I can hide components. And when I have eye visible next to mesh, I can click on show and it shows the mesh. Now I can click on surface with edges and I'm able to see the mesh. And like this, I can also show other parts of my mesh. And that's how you use external mesh in TCFD together with meshing process. Thank you for your attention.